Hello, Professor. This video is for Module 6, Energy Comparison of Fuels. Test your knowledge. Fossil fuels, coal, petroleum, natural gas are all fossil fuels. Biofuels, those include ethanol, grass trimmings, palm oil, sawgrass, wood, sawdust, manure. Hydrocarbon with single bonds between all the carbon atoms, and each carbon atom is completely surrounded by hydrogen atoms that is saturated. Hydrocarbon with at least one double or triple bond between the carbon atoms is unsaturated. SI unit of energy is a joule. The amount of heat energy required to raise the temperature of 1 gram of water by 1 degree Celsius is a calorie. Fossil fuels are renewable energy sources. That is false. During a combustion reaction, fuel reacts with an oxidizing agent, such as oxygen, to produce heat. Short chain molecules release more energy when they combust than long chain molecules. That's false. It's the other way around. Paraffins are a class of saturated hydrocarbons of varying lengths that are commonly used in the manufacturing of candles, crayons, foods, toiletries, and paints. That is true. The SI unit for energy is the joule. Exercise 1. Which fuel was more efficient, produced more calories per gram? Surprisingly, assuming of course I did the math right, the candle produced more calories per gram than isopropanol, almost double. Explain the difference in the efficiencies of the fuels you tested based on the chemical structures of the fuels. The paraffin tea candle must have been a longer chain of hydrocarbon, as it was able to produce more energy than the isopropanol, which I saw it's not. So I think I messed up. I'm not sure. Diethylene glycol is an organic compound used as a fuel in heating cans. Based on its structure and your data recorded in data table 3, how do you hypothesize its energy efficiency compared to isopropanol and paraffin wax? Structure appears to be much more complex than isopropanol and paraffin wax, which makes me more confused, as I noticed the compound structure of isopropanol is more complex than the paraffin wax. However, according to my math, the wax produced more energy. So now I'm guessing my math may have been off. What are the possible sources of error in this experiment? How could the errors be reduced in future experiments? I know for purposes of the experiment, it is assumed that all the energy given off is absorbed by the water. But based on laws of thermodynamics, some energy had to have been lost in the process, which is why the glass beaker was hot and air around the experiment would most likely have been hotter. Also, the tea candle sat lower on the stand than the isopropanol did in the little thingy in its container, so there was more direct heat from the isopropanol than from the candle. Maybe for future purposes, the experiment could make sure they're both at the same height. Data table 1, mass and density of distilled water. Mass of 10 milliliters of distilled water, 9.33 grams. Density of water, 0.9333. Temperature of water in Celsius, 23.5. Fuel source, empty fuel canister. Fuel canister, isopropanol, water, 19.95. Fuel source, initial mass of fuel in grams. Fuel canister, isopropanol, and water, 24.53 grams. Tea candle, the paraffin, 10.2 grams. Fuel source, final mass of fuel. Final mass of the fuel canister with the isopropanol and water, 23.61 grams, and the tea candle, 10.03 grams. Fuel source initial temperature in Celsius for the fuel canister with the isopropanol and water was 23 degrees Celsius, and the tea candle and paraffin were 24.5 degrees Celsius. Fuel source final temperature for the fuel canister with the isopropanol 38.5 degrees Celsius, and with the tea candle 29.5 degrees Celsius. Fuel source, fuel canister, isopropanol and water 15.5 degrees Celsius. Tea candle, the paraffin wax 5 degrees Celsius. Fuel source calories absorbed by water, fuel canister with isopropanol 6,052.64, and the tea candle 1,952.46. Grams of fuel consumed for the isopropanol 0.92 grams, for the tea candle 0.17. Fuel canister isopropanol calories per gram 6,578.96, and for the tea candle 11,485.06. Combustion is an exothermic process that requires the interaction of fuel with an oxidizing agent. CO2 is one product of the combustion of methane. Corn, sugarcane, and waste material are all renewable energy sources. Hydrocarbon-based fuels are an example of non-renewable energy source. Natural gas is an example of biofuel that is false. The hydrocarbon-based fuels are an example of non-renewable energy source. That is true. Saturated hydrocarbon contains only single bonds. For molecules with the same number of carbons, saturated hydrocarbons release more energy per molecule of fuel than unsaturated hydrocarbons. That's true. 10 milliliter volume water has a mass of 9.90 grams. Density of the water is 0.990 grams per milliliter. A fuel was burned for 5 minutes, increasing the temperature of 10 grams of water with a density of 1 gram. By 9 degrees, the fuel released 90 calories. Paraffin wax is a more efficient fuel source than isopropanol. True. Compare the energy value to the energy values of paraffin and isopropanol. Is methane a good choice of fuel? Calories per gram for methane would be much lower than isopropanol and paraffin, but I'm not entirely sure my math is accurate, and that's a true statement. Looks like that's all I have, Professor. Thank you.